Two masses 6 and 2 units are at positions 6 I cap minus 7 j cap and 2 I cap plus 5 j cap minus 8 k cap respectively. Deduce the positions of their center of mass. So we have two masses of 6 units and 2 units at these two positions. So these are the vectors, position vectors. Let us take this one as R1 and this one as R2 and this one as M1 and this one as M2. Now how do we find the position of center of mass? We know already. This one position of center of mass is equals to M1 R1 plus M2 R2 by M1 plus M2, where R1 and R2 are taken in the vector forms. The value of M1 is 6, value of M2 is 2 and value of R1 and R2 are written, and we are just multiplying it and we are just calculating the answer. So the final answer is 5 I cap minus 4 j cap minus 2 k cap. So the coordinates of center of mass will be 5, minus 4, minus 2. Locate the center of mass of system of 3 particles of masses 1 gram and 2 gram and 3 gram placed at the corners of an equilateral triangle of side 1 meter. Okay. Now let us see the answer. So yes. So this is the equilateral triangle of each side 1 meter, and there are 3 masses M1, M2, M3 of 1 gram, 2 gram and 3 gram respectively are placed in the each vertices. Now we have to find the position of center of mass. Okay. So here we will definitely be having both x coordinates and y coordinates. So let us find the center of mass for the x axis first. That is m1 x1 plus m2 x2 plus m3 x3 by m1 plus m2 plus m3. Now what is the value of m1? 1, m2 2, m3 3. Now we have to find the position of center of positions of x1, x2 and x3. So if you take x1, so this is the x1 and it is 0. So let us write 0. For what about x2? This is x2. So this whole distance, we know this is 1 meter. So x2 will be 1 meter from this point. So this is the reference point 0 we have taken. What about x3? So x3 is this point. So what is the value of this distance in the x-axis? So that is x3. If the whole distance is 1 centimeter, then this half thing will be 0.5 centimeter. Sorry, 0.5 meter. So we have taken that. By m1 plus m2 plus m3, that is going to give you the value of xcm. How do we find the value of ycm? That is m1 y1 plus m2 y2 plus m3 y3 by m1 plus m2 plus m3. What about the value of m1 and m2 and 3? There is 1, 2 and 3. y1. So y1 is 0. Yes, it is clear from this point. What about y2? So y2 is also 0 because the value of y-axis here is 0 only. What about y3? So this height we have to find. Let us see how we are finding this. So this is how we are going to find the value of the height, that is y. This one I have taken it as x. Okay. So this is the triangle, equilateral triangle, each of side 1 meter. So this half distance will be 0.5 meter, and the angles are 60 degree. Everywhere it is 60 degree, and we know that, and we have to find this length. So using tan 60 I can find. Okay, tan 60 is equals to opposite by adjacent. So what is the value of opposite? That is x. Adjacent one is this one, so that is 0.5. So x is equals to root 3 into 0.5, that is root 3 by 2. So this is one way, and there is another way. So in this way we are just using the square of hypotenuse is equals to the square of addition of squares of the remaining two sides. So we are using that one. So here the hypotenuse is this one, that is of 1 meter. So 1 square is equals to the other two sides. So that will be 0.5. So 1 half square plus x square, that is another side. So 1 is equals to half square plus x square. So on solving we are getting again x is equals to root 3 by 2. So by using both ways you can get the answer. So yes, now we got the value of y3, that is this length we have got now, that is root 3 by 2. By substituting it you can get the answer root 3 by 4 meters. So that is the answer for this question, x centimeter and y centimeter. Okay. A particle of mass 0.2 kg is moving with velocity 4 meter per second towards east, and another particle of mass 0.1 kg is moving towards west on the same straight line with the velocity 5 meter per second. What is the velocity of center of mass before and after collision? Okay. Now before collision, what was the condition? The mass of 0.2 kilogram is moving with velocity 4 meter per second towards the east, and another particle 0.1 kilogram is moving towards the west with 5 meter per second. Now velocity of center of mass, we have already seen it as m1v1 plus m2v2 by m1 plus m2. So value of m1 0.2, m2 is 0.1. Sorry, m1 is 0. Yeah, correct only. What about v1? It is 4. What about v2? It is 5. But why do we take the negative sign? Because it is moving in the opposite direction, so we can take minus 5 by m1 plus m2. So here you are going to get the answer 1 meter per second. Now we have to find what is the velocity of center of mass after collision. So if v1 dash and v2 dash be the velocity of two particles after collision, then velocity of center of mass after collision can be written as, so after the collision we can take the new center of mass, so velocity of the new one after collision. So that is v dash cm is equals to m1 v1 dash plus m2 v2 dash by m1 plus m2. Now the mass is going to be the same. The thing changed is v1 dash and v2, that is velocity after collision is changed. So please note here there is no external force acting, so we can take the total momentum before collision is equals to the total momentum after collision. Then m1 v1 plus m2 v2 equals to m1 v1 dash plus m2 v2 dash. So m1 v1 dash plus m2 v2 dash, that is equals to simple m1 v1 plus m2 v2. So what is m1 v1? That is 0.2 into 4. m2 v2 is 0.1 into minus 5. So that gives you the value of 0.3. So this whole value, that is m1 v1 dash plus m2 v2 dash, has the value of 0.3. Now how do you substitute this? So yes, so this value m1 v1 dash plus m2 v2 dash, that is 0.3, you have to substitute it here. So 0.3 by 0.2 plus 0.1, that is also 0.3. So that is equals to 1 meter per second. So this is a new model question, please note it. A pulley fixed to a ceiling carries a string with the bodies of mass 3m and m attached to its end. The masses of the pulley and the string are negligible and friction is absent. Find the acceleration of center of mass. So if this is the condition, the mass of one is m and another mass is 3m, then we know how to find the acceleration. That is m2 minus m1 by m1 plus m2 into g. Or else you can also find it using the free body diagram. You are going to get the value of same acceleration. Okay, then 3m minus m by 3m plus m into g. So acceleration you get it as g by 2. Now the acceleration is same for both the masses, but their direction is different, so please note it. So this mass will move upward because it is lighter in weight, and this mass 3m will go downward because it is heavier. So acceleration of this m will be upper side and this 3m will be on the towards down, okay, towards in the lower direction. So yes, the directions are different, but the magnitude is same. Okay, ACM, that is acceleration of center of mass in the direction y direction, that is m1 a1 plus m2 a2 by m1 plus m2. So m1 m into a1, what is a1? It is g by 2 plus 3m, m2 is 3m and a2 is minus g by 2. So if you take one as positive, one side, one direction as positive, you have to take the another direction as positive and negative by m1 plus m2, so m plus 3m. So this is the answer you will get. That is minus g by 4 is the answer. So if you take in the horizontal direction, there is no movement, so you will not be finding any acceleration in the horizontal direction, so that is 0. In the HCl molecule, the separation between the nuclei of two atoms is 1.27 angstrom. Find the location of center of mass of the molecule. The chlorine atom is 35.5 times heavier than a hydrogen atom. Okay, there is a HCl molecule, which is a two molecular system. Yes, one is H and another one is Cl. And if we assume, so if this is H and this is Cl, these are two atoms we assume. If we assume H at x is equals to 0, then we can take the respective distances and let us find the answer. So again, there is only going to be xcm. Okay, xcm is equals to m1 x1 plus m2 x2 by m1 plus m2. Now, okay, so if this is m1 and this is m2, so we can say m2, that is chlorine, is 35.5 times heavier than hydrogen, that is 35.5 into mass of hydrogen atom. So I can write m2 as 35.5 times m1. Okay, I hope you get it. and x1 is 0 because this position we have assumed it as 0. And what is the distance of chlorine from hydrogen atom? That is 1.27 Armstrong. So this distance is 1.27 Armstrong. Yes, now let us find one. So m1 is that is m1. The value is given just as m1 into 0 because the position is 0 plus m2. It is 35.5 times m1 into the distance between them. Okay, so that is actually from the reference 0 point we have to take the distance, and yes, we are taking it as 1.27 because the distance between the two is 1.27 Armstrong by m1 plus m2. That is, yes, 35.5 m1 plus m1, so that is 36.5. So on solving you are getting 1.235 Armstrong. So this is the position of center of mass. A child is sitting at one end of the long trolley moving with a uniform speed v on a smooth horizontal floor. If the child gets up and runs on the trolley in any manner with speed u, what will be the speed of the center of mass of the system? Trolley plus child. Now there is a trolley, long trolley, which is moving with a speed v, and there is a child in it, and it is and that child is, if the child moves with the speed u in any direction, then what is the speed of center of mass? That is being asked. The speed of center of mass of the system will remain unchanged, that is equal to v, because no external force acts on the system. The forces involved, such action, reaction, friction, when the child runs on the trolley are internal to the trolley plus child system. So there is not going to be change in the speed of center of mass. Okay, because there is no external force. So if there is no external force acting on the system, then the position of center of mass, speed of the center of mass is not going to be changed.